Do have a proportionality problem here. Because y is inversely proportional to x. You can't see the whole thing in the screen. Y is inversely proportional to x. And I break it down. I could just say, okay, y is 12 when x equals 4. So what's y if x equals 10? I didn't have to have all the rest of this stuff in here. I'm trying to prompt you. Just to, see if you follow the prompts. You gotta get used to the whole thing. In other words, normally, all you're gonna see is y is inversely proportional to x. I'm not gonna ask you what the proportionality equation is. You need to know. If y is 12 when x equals 4. I'm not gonna ask you what is k. I'm gonna ask you what is y when x equals 10. That much. All right. So we have to identify the proportionality equation. Well, inverse proportionality y equals k over x. Whatever k is, if you divide it by bigger numbers, you're going to get smaller y's. Bigger number goes into k more times. Smaller number goes into k more times than a bigger number. So the bigger x is, the less k is. That's what we mean by inverse proportionality. And that word inverse is going to get very important for calculus, if it hasn't already, when you do inverse functions. And we've talked about that. We've made some tables for inverse functions and so forth. And we're going to be doing that this weekend for calculus. So this is not an inverse function. This is inverse proportionality. Okay. But inverse means something's reversing. In this case, if x gets bigger, y gets smaller. Okay. Anyhow, there's your inverse proportionality. Okay, so we check that. And then you're always going to have something like this. Gives you a value of y when x has some other value. You can plug those values in here because they occur simultaneously. They occur at the same time. They're associated with each other. And that says that 12 equals k over 4. So 12 times 4 equals k over 4 times 4. All right, 4 over 1. But it's obvious then that we could reverse the 1 and the 4 without changing the value of the fraction. We'd end up with 4 over 4, and that'd be 1. So we'd end up with k. So k equals 48. Well, now k equals 48. The specific equation for this situation is what? Well, we know it's y equals k over x. We know we're going to have different values of x and different values of y, but k is always going to be the same because the definition of proportionality says that this is true for a constant number k. K is a constant number. If k is a constant number, we find out what it has to be. K has to be 48 for this particular specific situation. So y is 48 over x. Okay, well, y equals 48 over x. If x equals 10 then, and this over allergies is affecting my ability to write zeros, but if x equals 10, then y equals 48 over 10, which is 4.8. And we're done. They're very simple, but you got to practice the procedure and you got to know how to identify your proportionality. Now there's more. Another example. Y is inversely proportional to x squared. Okay, y is inversely proportional to x squared. X equals 2, y equals 60. What's y if x equals 6? Okay, well, first of all, y inversely proportional to x means y equals k over x. Y inversely proportional to x squared means y equals k over x squared. Okay. So we get 60 equals k over 2 squared. And we can easily solve this equation. Just square 2, you get 4. Multiply both sides by 4. Coincidentally, the same thing we did over here. Then you get 60 times 4 is 240. Thus, x equals 6. Y equals 240. Wait a minute. You skip one step, but I want you to include the specific proportionality. Is y equals 240 over x squared. So if x equals 6, y equals 240 over 6 squared, which is 240 over 36, which is I believe, well, let me write it in fractions. Okay, I'm gonna reduce the fractions. So I divide both sides by 6, I get 60 over 9, and that even reduces down to 20 over 3. And that's the lowest terms, and that's 6 2/3. That's a point. But we see that we can do this. So there we have our result. And see what happened. X got 3 times as big. But because of the square there, it turns out y gets 9 times smaller. 1/9 of 60 gives you the 6 2/3. Excuse me. Okay. All this writing. I don't even feel that bad, but a little bit off. Okay. Anyhow, does that make sense? I hope so. If not, review the video. Or look at the open math videos. Does she have to yell? I can't get her to go quieter. I can turn my speakers down. Okay. I don't know how loud that is out there. Okay, it's all right. It's new computer, really good computer. Big transition over the weekend, cost me some time, but it's worth it. Okay, so we got this equation, okay? Now, this looks like a perfectly innocent equation that you can solve. Okay, all you have to do is multiply both sides by the common denominator, right? So, and I'm gonna actually make this 4/3 over, okay? Common denominator is three x, so you do three x multiplied by two over x. Quantity two over x plus three x equals three x times 4/3. Well, we can multiply this out. Get three x times two over x. And since I'm multiplying by fraction, I'll write that as three x over one times two over x. Plus three x times three x equals three x over one times 4/3. Well, we can see that this comes out the same as x times 6 over x, and x divided by x is 1. So this is just going to be 6. What's 3x times 3x? Write that down. Tell me what 3x times 3x is. 3x times 3x. Make a little note over here. See that, yeah, 3x times 3x. Could be written in different order. It's 3 times 3 times x times x. Right? And 3 times 3 is 9. Now finish it for me. What's x times x? Okay, so what's x times x? Well, with this prompt, people appear to know that that should be x squared. And if you got an x here and an x here, you're multiplying. Okay, those x's are going to be multiplied because these four numbers here, these four quantities, 3x, 3x, are all multiplied together. You change the order of the multiplication, get 3 times x times x, and it's obvious. You got 9x squared. So we have 9x squared. Now, 3x over 3 is just going to give us x, and it's going to give us 4x. I'm not going to go through the details of that analysis, but we get 6 plus 9x squared equals 4x. Okay, can you solve that for x? Okay, now if you don't know how to solve this, you might take comfort in the fact that only one entering pre-calculus student out of maybe 30 would be able to solve this equation the way I've written it. Okay, although 25 out of 30 should be able to if they're learning the algebra that the SOL tells them they're learning, but they're not. Okay, algebra teaching is aimed at the SOL test, not at thinking or learning, and that's one problem. There are others. After effects of COVID, it's interrupted the whole educational process. So now we're finding that people have no clue. Okay, even if I rearrange this equation, I'm going to rearrange it to see if anybody has a clue of what to do. And I think some of you might. Okay, so I'm going to subtract 4x. Now, among other things, you see things like people try to add the 6 to the 9. You need to review the order of operations. There's an order of operations assignment. Go back and review it for practice. Make sure you understand the order of operations because we can't keep stumbling over order of operations, okay? Also exponents. Make sure that you've reviewed exponents. These are just things that you absolutely need that we can't spend too much time here doing, because we need to build on those skills, okay? And we can do some. I mean, this is a support course. Okay, if we find there's a problem, but we really need to go back and review these things. Okay, So anyhow, we do this. Why do we do this? Well, don't worry about why. Just do it. Okay? Well, on the right side, we get zero. And that's why we did it. We want zero over here for a reason. I'll go. And then I want to put these in decreasing order of x. I can't add the 9 and the -4. I can't add an x squared and an x. They're unlike terms. They have different values for different values of x. And x is something that can take any value. So 9x squared and 4x don't combine. So we have 9x squared minus 4x plus 6 equals 0. Okay. What are we going to do with that? Well, let's write it up here. 9x squared minus 4x plus 6 equals 0. Okay, any ideas? Okay, now, not getting any ideas, which isn't too surprising. This is something a little bit unfamiliar, maybe. Haven't seen it in a while. This has an x squared in it. It means it's not a linear equation. This is not in the form y equals mx plus b, and it can't be put in the form y equals mx plus b. Okay? It's not in this form, and it can't be put into this form. Because you got that x squared. Because of x squared, which won't go away. That x squared not going anywhere. You can, I mean, you can move it, you can subtract 9x squared from both sides. Or you subtract 5x squared from both sides and split the x squareds from both sides. It's not going to help. Okay. So just adding things to both sides and multiplying both sides by the same thing is not going to be sufficient. It is sufficient for linear equations. All the equations you've seen so far. You just have to know what to add, what to subtract, what to multiply, what to divide, and when to do it. Okay? That's linear equations. Now, quadratic equations, which is what this is. Okay, now this is the slope intercept form. Okay, you also have the intercept form and point slope form and all that stuff. Okay, so a lot of ways you could write this equation in different forms, but it can always be rearranged to this. And of course, this can be rearranged to any of those forms. The quadratic equation has a different form, and the general form, the one that's probably easiest to understand. If ax squared plus bx plus c equals 0. Now, is this equation in the general form? Look at this equation and look at this form. Okay, people answer quite well on this. Okay. I asked, what would you replace a by in order to get this equation? Well, let's just write it out. Place A by 9. B by -4. C by 6. Okay. Now, if we had it in different order with the x squared here and the 6 here and the minus 4x in the end, you would still have A equals 9 because A is what's in front of x squared. Doesn't matter what order I have these terms in. A is the number in front of x squared, B is the number in front of x, and C is the number in front of nothing. Okay, C is the number that stands alone. All right. Make sense? Okay. Now, I've given you a little more, maybe it's jog your memory. Let's see. Okay, it doesn't seem to be coming back. It is coming back, doesn't seem to be coming back all that quickly, so we're gonna move on. Okay, so what we use is the quadratic formula. Now, there are other ways to solve it, but we don't try to isolate x on one side because we've got an x squared and an x. Okay, and we can't split them, we can't combine them. It's not gonna work. We put the equation into this form, into this general form, ax squared plus bx plus c, have to have 0 on this side. And of course, that's why I subtracted 4x from both sides. So I would get a 0 on one side. Okay. And then I'd have an ax squared and a bx and c. Okay. Or we use the quadratic formula. The quadratic formula is just I usually state it in more words, but for right now, you'll see the full statement when we get to it in pre-calculus, okay? And the full statement is if ax squared plus bx plus c equals 0, then solutions are x equals -b plus or minus the square root of b squared over minus 4ac divided by 2a. That's it. Now, you should know that formula from now on. I mean, like, by next time, I should never have to tell you what that formula is. Okay? You simply have to know it. And you should do enough problems and write this out enough. And when you do the problems, write the blame thing out. Just don't start plugging numbers into your calculator. You won't remember anything. Okay? So if you would, go ahead and now plug the numbers A, B, and C in here and see what you get. Okay, I think everybody's plugged the numbers in correctly. And, okay, so as I say, most people have plugged the numbers in correctly, not incorrectly. Okay, there's a distinction. So if we do this, we get x equals negative of -4. Now, if you have the negative in front of the -4, you just have -4. Because there's a tendency to lose one of the negatives, and it's very important to get the negative correct. And then plus or minus the square root of b squared, which is the square of -4. And I'll make sure if you're squaring -4, you put the -4 in parentheses. Because if you don't, you might enter it in the calculator that way. And the calculator, if it follows the order of operations correctly, you're going to square the 4 and leave the negative there. Don't have the parentheses, the negative isn't part of the square, only the 4 gets squared. And then you tack on the negative. So you gotta be careful about that. You wanna write that in parentheses. And then minus 4AC, that's minus 4 times 9 times 6. I think most people have most of that. And that's over 2 times 9. The two cautions, make sure you have the negative in front of whatever B is. So if B is negative, you're going to end up with a positive number there. And make sure you got parentheses around any negative number that you square. So we get 4 plus or minus the square root of 16. Now what in the world is 4 times 9 times 6? Well, it's 4 times 54, which is 260. And that's over 18. So that's 4 plus or minus the square root of negative 200 divided by 18. So there are two solutions. X equals 4 plus the square root of negative 200 over 18. And X equals 4 minus the square root of negative 200 over 18. Neither of these is a real number. They're both what we call complex numbers, and we're not going to talk about that right now. We're just going to confine our attention to real numbers until we get to complex numbers, and probably month after next. Okay. Neither of these is a real number. Why not? Anybody tell me why this? Okay, so then what I asked is, can anybody tell me why neither of these is a real number? And somebody said, well, you got that square root of negative 200 there. And the square root of a negative can't be a real number. A real number is either positive or negative. If it's positive and you square it, you're going to get a positive, right? Positive times a positive is a positive. If it's a negative number, if the square root was a negative number, then you'd get a negative times a negative, which is positive. Okay. So whatever you think the square root is, if it's a real number, it's not going to, there's no real number that's equal to the square root of negative 200 because it can't be negative, it can't be positive. Okay. Because if you square a negative, you get a positive. You can't get a negative number by squaring. So you really need to understand that and sort it out. Okay, so neither of these is a real number. I'll say since no real number is squared, it'd be negative. Thus, the square root of negative 200 isn't real. Now, it turns out that if you include imaginary numbers, you get whole new branches of mathematics that are extraordinarily powerful for engineering and a lot of other, in physics and a lot of other stuff. Okay, so this whole idea of imaginary numbers is not just something we made up so we can solve quadratic equations. Okay, it's got real interpretations to the extent that it turns out you can't really model reality without imaginary numbers and complex numbers. No, but we'll see later what some of that means. We'll touch on it at least. Okay. Well, that always works. If we got an equation in this form, we can always plug the numbers in here. And first of all, find out if we have a real or a complex number solution. Okay. And if we're trying to graph this quadratic function here, we need to have real solutions. Okay. Well, I'm not saying that now. If we want the graph to go through the x-axis, it's got to have real solutions, and we'll see why that is. Okay, so I want to talk about, so there's a method. It's universal. It always works for quadratic equations. You tell whether they have real solutions, and if so, what they are. And it also tells you what the complex solutions are. Now let's take this equation. X minus 5 times x plus 3 equals 0. Can you give me a value of x that satisfies that equation? A number you can replace x by in order to get 0. Okay, nobody's giving me any suggestions. Let me just ask you this. Just work it out on your paper. Plug in x equals 5. See what you get. Okay, rewrite that equation, but replace x by 5 and then work it out. Excuse me. Okay, so plug it into this expression, the whole equation, okay? Not just in here, whole thing. So you got 5 minus 5 times 5 plus 3 equals 0. Well, 5 minus 5 is 0. Then 5 plus 3 is 8. What's 0 times 8? Well, it's 0. So can you show me with your fingers what another solution would be? What other number could you put into this equation and get 0? I think people know, but nobody seemed to want to answer, show me their fingers, whatever. We can make x plus 3 0. X equals 3. Yeah, let's be about it. X plus 3 will be 0. Be 0. Now, we can write this out a little more formally. Okay, so I've got the equation x minus 3 times x minus 5, sorry, times x plus 3 equals 0. This splits into two equations. X minus 5 equals 0, or x plus 3 equals 0. We can solve both of these equations very easily. We can add 5 to both sides here, and we get x equals 5. Or X plus 3 minus 3 equals 0 minus 3. So that X equals minus 3. And then we can plug each of these numbers back into the equation and check it. Now, let's look at what this equation looks like if we expand it. By expanded, it means we use the distributive law to do this multiplication of this expression by this expression. Now, x minus 5 times x plus 3 is just x minus 5 times x plus x minus 5 times 3. That was x minus 5 multiplies each term in here. So we have x minus 5 times x here and x minus 5 times 3 here with a plus in between. Okay. Then we can multiply this out. We get x minus 5 times x is just x times x minus 5 times x. And over here, x minus 5 times 3 is x times 3 minus 5 times 3. So this gives us x squared minus 5x plus 3x minus 15 equals 0. Negative 5x and 3x are like terms. We can add them. We get x squared minus 2x minus 15 equals 0. Okay, well now, this equation is completely equivalent to this equation, if I've done it correctly. Take this equation and use the quadratic formula on it. Identify A, B, and C, and plug in the quadratic formula to see what you get. Okay. Well, if we now plug this into the quadratic formula, well, let's see, we got x squared minus 2x minus 15 equals 0. Okay, the form is this. Now, I really recommend that you take notes or go back and look at the videos and write things out as I'm writing them out. Or maybe as you see Open Math writing them out, okay? You want to write everything out. I like saying, okay, here's the form. So this is of this form with a equal to 1. Now, you don't see a 1 in front of x squared, but obviously, if a is 1, you have 1x squared, and you don't need to write the 1 because you've got 1. You got an x squared, you don't need to write just that this is 1x squared, okay. B equals -2, and C equals -15. So the solutions are, and you write that out. If you write that out, you're reinforcing the idea that this is what we do to get the solutions. If you're just kind of doing it by rote, so you get the right answer, you're going to tend to forget it a lot quicker than if you write out the words that connect things. I'm recommending that. Don't require it, but I do recommend it. Okay, so x is negative of -2 plus or minus the square root of -2 squared minus 4 times 1 times -15. All that divided by 2 times 1. Well, that's 2 plus or minus 4 plus 60. Square root of 4 plus 60, because square -2 gives you 4. 4 times 15 is 60. We got a negative here, so we get -60, but then we have a negative of that, which gives us a plus 60. So this is 2 plus or minus the square root of 64 over 2, which is 2 plus or minus 8 over 2. Okay. Our solutions are x equals 2 plus 8 over 2, which comes out 5. And x equals 2 minus 8 over 2, which is -3. Now, why should we get 5 and -3? Well, this is the equation that we solved up here. We solved it up here by looking at its factors. Okay, this equation started with a product of 2 factors that was equal to 0. So one factor or the other had to be 0, and it was easy to solve and find out what the solutions were. When we sort of complicated the thing for illustration, we took exactly the same equation. We applied the distributive law a couple of times, and we got the equation x squared minus 2x minus 15 equals 0. And we just solved that equation using the quadratic formula, and we got solutions 5 and -3, the same as the solutions we had here when we did it in factor form. Okay, so there are 2 ways you can solve a quadratic equation. One way is if you can factor it. If you put it in factor form, that's pretty easy. And if you can't put it in factor form, then use a quadratic formula, which is also pretty easy. You just got to be careful about your numbers. Okay. Okay. Well, you do have the assignment on the quadratic formula for next time.